Sige. Good day, everyone. We are the Group 3 presenters. I'm Manto James as the first. Next slide, please. This will be the main topic of our discussion, which is to describe the difference between vector and raster charts and to determine the procedures and setup of XD system, display, functions, and integration. Next slide. First and foremost, let us define the types of XD charts. Upfront, the raster chart or RNC means raster navigational chart. RNCs are the direct copy of a scan of paper charts. It is it looks identical to a paper chart as all the information shown is directly printed. The chart only grows larger or smaller as per the zooming, and when rotated, everything rotates. So this is just a paper chart but a transferred to electronic, and somehow, for simply terms, it is a scan reproduction of a paper chart, and it is computer-based system. And this is just the definition. As we go to the comparison, there's a lot of aspect or features you will know about this. Now I'll give the floor to Ozone.
So, vector chart or ENC. ENCs are computer generated charts. The details on an ENC can be turned on and off depending on the requirement of the user. Objects on the ENC can be clicked for more details on the same. Depth can also be monitored to obtain a warning with regard to grounding. When zooming, the features grow large or small, but the text remains the same. Merely a representation of the database of information. All of the same information that is available on the raster chart is present with many significant additions. So the next reporter will be who's the next reporter? So by the way, this is the difference between next slide. The difference between vector and raster chart. So as you can see, that is the the vector chart and the raster chart. So the next reporter.
So good day everyone. I am Gabriel Rio. So the difference between vector chart and raster chart is first, the vector chart is a computer generated charts or smart charts and made up by mathematical formulas, and the vector charts need less electronic storage room is required. Then the vector charts have a clean look because they present has less information on any one screen. Then the user can click on different features such as light or voice to retrieve additional information not available in the paper or rasters. Then in raster charts, the raster chart is the recopy of paper chart. Then it was digitalized by scanning the paper chart and converted each line to a raster picture element or pixel beyond georeferencing. Then the raster chart requires a lot more electronic storage space. Then the raster images are made up of a number of pixels and all different colors at the appropriate density or scale. These pixels make up an image. So that was the difference between Victor chart and the raster charts. And Karit mga pobre will continue.
Good day everyone, I am Cadet Makapobre and so the the differences of vector chart and raster chart. So continuation, the vector chart. The vector chart is at any time it shows the shape position on the chart in true motion with or without radar. It overlay an ARPA integration in one display, updates the chart by satellite and thereby increase the speed of updating. Automatic chart updating, simple voyage planning, anti-grounding warning, tide corrected deep contour. In the raster chart, this is the cannot select different scale charts. May affect the readability of chart, text and symbols. Not possible to gain additional information. Not possible to display a ship safety contour or safety depth. Different colors may be used to show similar chart information. Displayed at the scale of the paper chart. Excessive zooming in or out can seriously degrade RCDS capability. The next report here is
Nabaha pre.
the next reporter will be Kadit Navaha.
Good day everyone, I am Cadet Nabaha. Determine the procedures on setup of ICDIS system, display, function, and integration. ICDIS setup. Ensure the chart motion, chart orientation, screen layout, color palette, and additional ENC settings are configured correctly. Ensure the correct display setting is available for execution of navigation in accordance with ICDIS check-off cards of pilotage and confined waters and coastal navigation and open ocean.
Cadet Kenneth.
Kinis.
So display. So important setting for this display. So shallow contour value is used to tell this what what is the value of shallow water for our draft. So this is the value of depth below, which is defined for the vessel to get aground. The shallow contour value need to be equal to or more than the draft of the vessel. So the shallow contour value must be equal to or greater than the vessel draft. So the safety contour is the line over which we can navigate without worrying about the water depth. So the single depth setting like this is the safety depth, which is can maximum depth at which we can safely travel. Deep water contour is a subjective phrase, and the user is free to set it to whatever he considers to be deep. So that's the display this. So next reporter.
So good day everyone. I am Cadet John Rex Petalcorin and I am the reporter of function of ICDIS. So ICDIS provides continuous position and navigational safety information. The system generates audible and or visual alarms when the vessel is in proximity to navigational hazards. Integrates position information from position, heading, and speed through water reference system and optionally other navigational sensor. So the function of ICDIS is that it is an aid to navigator to have a safety voyage and avoid collision and grounding at sea.
So good day. So I am Decadet Relito Pimaga Jr. reporting for the integration. So AIS ICDIS integration offers unlimited possibilities. Data is promptly shown on the ICDIS electronic chart of ships in the area, allowing navigators to make immediate use of it. Monitoring ship traffic. Advantages inherent in the use of AIS systems as a tool for VTS and pilot services are clear. So when integrating AIS and ECDIS, we have the following. First, we have the collision avoidance and surveillance. Second, improved target identification. Third, graphic presentation of targets. Fourth, we have the local information services. Fifth, the monitoring ship traffic. And lastly, we have the enhanced communication facilities. So that's all.
So good day again. So in addition of our report, there is 19 bridge checklist ICDIS setup. One is the check primary position, fixing system is set up correctly and prove the ICDIS is correct by inputting a manual fix into the system. 2. Check system time is configured correctly. 3. Ensure ICDIS setup is replicated on all ICDIS units. 4. Ensure navigation tools are configured correctly. 5. Ensure safety depth and safety contour settings are configured correctly. 7. Ensure that all relevant overlays are loaded. 8. Ensure that area alerts are configured correctly. If system is in use allows alarm configuration. 9. Ensure that docking mode is configured correctly. 10. Ensure that navigation alarms are configured correctly, including safety frame, anti-grounding cone. 11. Ensure that route alarms are configured correctly. 12. Ensures that targets are configured correctly. 13. Ensures that preferred reader is selected. 14. Ensures that the vessel data is set up correctly. 15. Ensure the audible alarm is configured correctly. 16. Ensure the chart motion, chart orientation, screen layout, color palette, and additional NC settings are configured correctly. 17. Ensure the correct display setting is available for execution of navigation in accordance with this check of cards for pilotage and confined waters, and coastal navigation and open ocean. 18. Ensure the correct route is loaded for route monitoring. And lastly, the 19. Ensure the correct waypoint and route monitoring information is being displayed. That's all of our report, and I hope guys that our report will give you more information and help us both of us in the future. Thank you and God bless.